The Mac I was going to do this on decided to not update Zoom, so I'm on my other Mac, which means there will be no demo, I'm afraid, because the demo is not set up on this Mac. I was debating freestyling the demo, but I think it's going to go horribly wrong, so I think I probably won't, but we'll see how we get on. Which time we have. So hello everyone, and welcome to my talk that will be about serverless, Cloudflare, and there'll be a bit of history thrown in as well. I'm Ashley Peacock. I live in London because we're all sharing our locations. I'm a staff engineer, the kind of finance engineer in London, and I've been tinkering about with the web for about 20 years. In terms of agenda, just to give you an idea of what we're going to go through, we're going to talk about the evolution of complexity around building and deploying applications, and I'll kind of talk through a bit of the history about where it started, or at least where I started, and then where we are today, and why I think it's got a little too more complicated than it needs to be, and how we can take it back to perhaps how things were, but still more improved and better than they used to be. In software engineering, there's kind of a common way of talking about complexity regarding accidental versus essential complexity, where essential complexity is complexity you can't avoid because the problem domain is innately complex. So if you think about tax rules, for example, those are they are essentially complex because the tax system is complex. Accidental complexity comes in when humans get involved and they like to build things that are more complicated than they need to be. Maybe they have 10 different services all over the place communicating via 5 different protocols or whatever. And then you get a lot of accidental complexity. And that's what I think has happened over time with building and deploying applications. We'll then cover what is serverless that I think addresses a lot of these problems and takes things back to a more simple approach to building and deploying applications. And then we'll take a quick tour of Cloudflare to finish up. So a bit of history lesson, going back to about 20 years when I started tinkering with applications when I was about 13. So now you get my age now. And when I started out, I learned PHP, which is still incredibly popular today. And effectively, you would write the code on your device. You would upload it using something like you can see on the left, which is FileZilla, which is a really popular FTP client. And I imagine some of you haven't even used an FTP client because I think it's really not very popular anymore, but it effectively allows you to transfer files from one location to another. So you would write your code, you'd upload it onto some shared hosting that would be shared between probably thousands of other people because you're all paying £3 a month for this little space. And if one of these websites got a lot of traffic, the chances are that all of the websites on that server would crash. It wasn't great, but it was, I was 13, 14, it's about what I could afford at that point. And it's still, I think, quite popular, say, when you start out. On the flip side, if you were a big enterprise company, you didn't use these shared hosting, of course, you would use dedicated servers. That unfortunately involves buying servers. You then need to ship them to a data center. You need to pay to host them in a data center. And you need to pay probably someone to maintain those servers for you. And that lead time can be anywhere from weeks to months, depending how long there is a wait for the servers. It worked well, but Amazon decided they wanted to change the game a little bit in 2006, and they introduced EC2. So rather than waiting months for your server to arrive, you could go to Amazon and say, hey, I'd like a server, please. And in 2 or 3 minutes, for virtualized servers, they will give you a slice of one of their servers. This solves 2 problems. One, obviously your lead time to get a server is a lot shorter because you're just getting one straight from Amazon straight away. And it has the other benefit of, though, even though it's shared, so you're renting part of a larger server, the resources are all allocated evenly. So you can't use more than you're allowed, which means that someone else getting a lot of traffic is not going to negatively impact your website. But it's getting a little more complex each time because now you're having to manage these servers yourself, which has its own problems with upgrades, programming upgrades, and all sorts. Whereas before, you were offloading that to someone else, you're now doing it yourself. You can obviously hire someone to do that still, but still more complexity. So 2013, Docker was released, and specifically, Docker allows you to create what are called containers. And very briefly, because I think containers on their own are probably their own talk entirely in their own right. But rather than taking your code and uploading it to a server, you package all your code up in a container, and you give that container to someone like Amazon, and they will host it for you on a server. And when a request comes in, to that container, your container will handle that. And the difference here is that container has everything. So it has the operating system, it has the programming languages, it has your packages. It's everything kind of tied in a nice bow, and you just upload it. But you now obviously need to know about Docker. You need to know how to build those containers. You need to know about the operating systems, all sorts of things that, again, you didn't need to know before. It definitely is an improvement in that it packages everything nicely, but it is still adding complexity and more things you need to learn. I have one more on this lesson. So now everyone loved Docker. They loved their containers, but they had, let's say, 100 services. That means you have, for each service, you have a container, you now have 100 containers. So how do you manage all your 100 containers that all need to talk to each other? There needs to be security about which container can talk to which container, so forth. So you get Kubernetes, which a lot of companies rapidly picked up. It's kind of like, I don't explain it, but it's like a big kind of the orchestrator of your entire kind of architecture. It does everything you can possibly imagine. So it does everything from communication between your containers, the security between them, and it will even increase and decrease your number of containers that are running based on load and all sorts. But it is wildly complicated. So I think if you try to use it and you had no idea what you're doing, you're gonna make a big mess. And it's got such a steep learning curve that it's just very complex. So I don't think it needs to be this complicated. So that's when serverless comes in. So going to the agenda, we're now going to talk about what is serverless, because Cloudflare is a serverless platform. So everything we've just talked about before, like you rent your servers at the end of the day. You are paying someone, hosting a server, you have to maintain and provision that server. Serverless is a little different because you are not provisioning and managing your servers. So serverless was born probably in 2008 when Google released App Engine. But serverless really gained traction in 2015 when AWS released Lambda. And Lambda is not just one thing. Anything can be serverless. Sorry, not Lambda, serverless. Serverless can be anything. It can be databases, it can be caches, services, whatever you like. In theory, anything can be serverless. But one of the main aspects of serverless is how do you run your code? If you haven't got a server to execute your code on, how does your code get executed? And that's where functions as a service comes in. So things like Lambda and Cloudflare all operate functions as a service. And rather than you uploading your code to a server, you would write your code as you normally would. You give it to one of these providers, such as AWS, Cloudflare, and they will handle pretty much everything else for you. You just give them your code, and whenever a request comes in, they will load your code and execute the request, and then get rid of it. I have a very quick diagram to explain. So the user, this is the normal kind of server-based architecture. So you have the user makes a request to a server, and the server returns a response. That server is running 24/7. You're paying for it 24/7, even if you receive no requests. How it looks in serverless is you have the user makes a request, and on the right, there is nothing currently running because you haven't received requests for a while. The provider, in this case Lambda, loads your code into memory, execute the request against it, and it returns a response. And then after a while, if another request comes in, it might reuse that function. But after a while, let's say you don't get any requests for 10 or maybe 15 minutes, it will all go away. So you're not running anything anymore. And what was spun up is not a server, it's just your code loaded into memory. So you're not maintaining any servers. There are some slight drawbacks depending on the platform. So with a server, your code is always ready to go. With serverless, you get things sometimes called cold starts, where when the request first comes in, it takes a little while for your code to be loaded into memory. But once it is, all the subsequent requests are a lot faster. I'll talk a bit later about how Cloudflare fixes that, but that's just something to be aware of if you're using serverless on other platforms. So what defines serverless? Because I think it's a very open-ended topic where if you ask 10 people, you're probably going to get 10 different answers from 10 different people exactly what it means. I don't think there's no kind of agreed, there's no overarching body of serverless that says this is serverless, this is not. It's very much kind of community, and if you like kind of Twitter or X discussions, there's always discussions about is this serverless or is this not serverless, and all sorts of fun things like that. But there are 5 kind of principles here from Memento, and Memento provide serverless caches primarily, among some other things. But they wrote their kind of serverless definition, and I quite like it, so I'll just put it in here, and I'll talk about each one kind of individually. The first one being, there should be nothing to provision or manage. So if you use EC2, like I spoke about, you have to create that server. It takes a few minutes. You then need to install the programming languages that you might need. And if you compare that to serverless, there's nothing to provision. You just write your code, hand it over to a serverless cloud provider, and they'll handle the rest, including generally routing traffic. So you don't need to worry about things like load balancers. If you're running a server and that one server dies, your application goes down. So if you're in a, working for a company, excuse me, that's not allowed to happen. So you would need to have multiple servers running just in case one crashes. And then you've got more complexity because now you need a load balancer that splits the traffic evenly between your multiple servers. And the area I work in insurance. It's very heavily regulated. So actually we have to run servers in the UK and the US. In case one goes down, then we fail over to the US and things like that. It gets wildly complicated, and serverless solves a lot of these kind of problems. So it should be usage-based pricing with no minimums. So sometimes you'll see some AWS products that are in air quotes serverless, but they will have a minimum pricing. So they might say, yeah, this is serverless. You pay for kind of, this many requests, but there's a minimum spend of $75, which is not really how serverless is meant to work. It's meant to be, you pay for whatever you use. So if you use one request, then you get charged for one request. If you get served 1 million requests, then you should pay for 1 million requests. The third one, it should be ready with a single API call. So when we talked about EC2, you have to wait for that service to be provisioned. It takes a few minutes. And that's the same with lots of services. They take a few minutes for the service to start and be ready. With serverless, it should be instantly available with no need to wait around for instances to be provisioned. So no planned downtime. So whether it's for security reasons or to get the new features of the programming language, there shouldn't be any downtime because you're offloading all the responsibility to whoever you're using. If you're managing your own servers, you need to take one of their servers down, upgrade it, and then put it back up again, and then take the next one down, upgrade it, and so forth. With serverless, because these are very small temporary kind of functions, if you like, you can spin those up at ease and down with ease. And if you want to flip between programming languages, that's super easy to do. With the server, not so much. But there should be no planned downtime. The final one I find a little superfluous, but I wanted to complete the list. But they say no instances, so no servers, which I think the prior 4 effectively make that has to be the case, but I think they want to be very explicit that serverless is not about servers. So if you want some examples of serverless, you may have heard from AWS. It has DynamoDB is one, so it's a key value kind of store from AWS and is serverless. And S3 is another serverless service. So it's object storage in the cloud where you can store images, videos, PDFs, whatever you like. And that one is also serverless. And of course, Cloudflare is serverless, and it's entirely serverless. With AWS, you'll get a mix of the two. So sometimes it can be hard to tell what's serverless and what's not, especially as, like I said, AWS use serverless in a kind of, they use it in a way that's not fitting with the principles I just outlined in some cases. So agenda. Now we've kind of set the stage. You understand, the history of where we started. The complexity grew over time, and also I think it was important to understand, if you're not familiar, what serverless is. Otherwise, the Cloudflare platform is not going to make much sense to you because it's all serverless and is very different to if you're used to using AWS or something like that. And the reason why I think Cloudflare is excellent is it's so simple. So AWS is not a bad platform. So I use AWS day in, day out for my day job. It definitely has a place. It's used by a lot of people. It's not bad. It's definitely not bad. But it makes things a lot more complicated than it needs to be in some cases. And I think especially if you're just kind of getting started, it's a very steep learning curve. Whereas with Cloudflare, it's very simple. And it's also like a joy to use. I feel like the platforms you use, they should kind of power you up rather than slow you down. And for me, I find Cloudflare allows me to move faster rather than AWS. I'm fighting with, I don't know, IAM permissions or access policies or something. It's gonna slow me down. I'm going to talk through kind of the building blocks of the platform. They'll be very familiar. It's kind of the bread and butter of most applications, but just applying a kind of Cloudflare lens over them so you know what they are. And then I'll talk about some specifics of the kind of Cloudflare platform that kind of really make it stand out. So the first thing you'll probably see if you try building something on Cloudflare are called workers. So workers are Cloudflare's implementation of functions as a service, and they're your core compute. So this is primarily where you're going to write most of your code and where most of your code is going to be executed. There are some important things to note, such as the runtime is called V8. So that's the same runtime that is running in your Chrome right now. So if you joined, via Chrome, it's the V8 runtime, which means it's not a full node runtime, but you can load a bunch of node libraries that you might need. Cloudflare has kind of polyfills for them, and I think over time they'll have full node support. But largely speaking, you can still do what you need to do, and you can install npm packages and all that kind of thing. It has native support for JavaScript, TypeScript, and recently Python. I think with the AI craze going on, they recently natively supported Python. And you can support pretty much any language as long as that language supports WebAssembly. And again, WebAssembly, probably a talk unto its own right, but it runs in your browser, and it's kind of a way to use more resources on your machine. It's a lot more powerful for kind of heavy lifting that you might need to do. So if you were building intense kind of computations or graphical things in a browser, like a game, WebAssembly would be perfect for it. But it's also something that any language can compile to, and therefore you can put it on Cloudflare. But if you're starting out and you don't mind writing in JavaScript, because I know some people don't like writing in JavaScript, I would start with JavaScript, TypeScript, or if you like Python, go for Python, purely because they're natively supported. So they're going to be easier to get off the ground with. And also, I mentioned there are no cold starts with Cloudflare. So Cloudflare does some magic where it sees a request come in for your code. And whenever you access a website these days, it's all encrypted over HTTPS with SSL, and that involves a handshake where your browser and the server do a little handshake between each other, and one says hello and the other one says yes, you can come in. While the handshake's happening, it happens really fast. It's like, a few milliseconds, but it's long enough for Cloudflare to load your code into memory, and then your code is ready to go. So there's no cold starts whatsoever. You don't get any delays. It's incredibly rapid. The other thing with servers, you're deploying them to one location. So if you log into AWS and you pick a region, you can deploy a server in that region. And like I talked about in my day job, we run servers in multiple regions, but that's more complexity. We need to route them to different locations and all sorts of things. With Cloudflare, your entire application is always global. And by that, I mean Cloudflare has a global network. If a user accesses your application from New York, Cloudflare will load the application in New York and serve it from New York. If someone else from London, where I am, loads the application, they will load your code in their London data center. In Australia, same thing. They have something like, I don't know, 350 data centers worldwide. So they have full global coverage, and that's going to reduce the latency for your end users. So if your application is, very is important, it's responsive, maybe a multiplayer game, for example, it's really important that's close to the user to reduce the latency. It's like a nice benefit of using the platform, if you like. And because of the way serverless works, the functions are kind of temporary. So you can't store state in your functions like you can a server. Things like file storage that won't be consistently available to you. So you need to keep in mind that your code is going to be kind of ripped out of memory and put back in. So be careful with what you're storing in memory. Don't store anything you need access to long term. It's going to get killed. Pages. So the workers are primarily kind of for backends. So if you want to build APIs, that's where I would reach for a worker. You can do kind of simple front ends with it, but if you want to deploy static or full stack websites, then Cloudflare has a product called Cloudflare Pages. And it has wide support for a variety of JavaScript frameworks. all the top ones for sure: Next.js, Astro, Svelte, Vue, Nuxt, and there's over 20 more. And you build it as you normally would. So like I said, I like it when the platform doesn't get in the way of what I'm doing. You can run, Next.js, for example, locally as you normally would. You can then deploy it to Cloudflare, and in between, Cloudflare has kind of adapters, if you like, that basically do some stuff to your code before it's uploaded, prepared for Cloudflare. And that way you develop as you normally would. And then when it's uploaded to Cloudflare, they do a little bit of transformation and everything works nicely. And there's also Git support for easy deployment. So you can deploy from your Mac if you want to, or Windows PC. Or you can connect your GitHub repositories to Git and it will build it for you. It will do everything for you on Cloudflare's dashboard. Those are the primary two products for the core application, if you like, so APIs or websites, whatever. And Pages also has kind of a workers add-on, if you like, where you can write your backend functions within your Pages product, and they get converted to workers. These using workers under the hood, but you're still using Pages. Take Next.js, for example, if you're familiar, it has server-side routes. When I talked about the build process and preparation, Cloudflare will take those server-side routes, convert them into what are called Pages functions, which are the workers, and it will do that at build time. So you still build it, same Next.js as you normally know, Next.js as you normally know. Cloudflare is doing the translation in between. And at the bottom of each of these slides, you can see the commands you would run to get started with these. So in this case, npx create Cloudflare at latest. And I can probably show you that bit. That bit I can demo you, but it will give you a nice kind of step-by-step of how to build these applications, and it will kind of scaffold it for you quite nicely. Most applications these days need to store state, and the most common one is a database. For that, Cloudflare has D1, and it is a relational database built on top of SQLite. So if you've ever used Postgres or MySQL or any other flavor of SQL, it'll be very familiar to you. If you've used document databases like Mongo, for example, it has support for JSON, so you can store JSON in the columns. There's some magic stuff that you can do with it where it can even kind of create dynamic columns based on the JSON, all sorts of fun stuff like that. And it has point-in-time backups, which are very useful. So you can basically back up to any second over the last 30 days. So if you delete your production database, you can just go back and get it any point in time. And yeah, again, the command at the bottom is super simple. So these are all created with one command, and it'll be available instantly. KV, so if you need some simpler storage, you might need cache. For Cloudflare, it's called KV. And it works in a very similar way to Redis, if you've heard of Redis, which is a key value store. So if you've used JavaScript or most languages, they have a concept of a data type that you can store keys and values in. In JavaScript, it's just basic objects where for a given key, it has a given value. And these key value stores that are kind of remote work in exactly the same way, where you say, under this key, store this value, and then also get the value under this key. And that's caches. R2. So R2 is your object storage. And so this is very, very similar to S3 if you've used S3, but it's where you can store files like images, videos, PDFs, commonly referred to as object storage or blob storage. But if you think about YouTube, it needs somewhere to store all its videos. That's where R2 would come in. You could upload them there. You can create as many buckets as you need, and buckets are just the kind of mechanism for a collection of objects. So you might have a bucket for videos, you might have a bucket for images. You can create as many as you like. You can expose those publicly. So if you want to, generate a PDF, for example, and allow people to download it, you can give them the link to your bucket, expose it publicly, and send them links so they can access this information. And you can also do fun things. This is kind of starting to introduce the kind of glue between the different products you get with Cloudflare, where you can trigger events when files are uploaded. So let's take the YouTube example. Let's say you want users to you're recreating YouTube. Someone uploads a video and it's in a massive video file that's not optimized at all for mobile devices. What you can do is you can put that in an R2 bucket. And when you don't want the user to wait around while you perhaps optimize it for smaller mobile devices, So what you could do is you can have an event fire whenever a file is put on R2, and then you can have something completely separate, a separate worker, for example, that handles when a video is uploaded, and it can generate that smaller mobile optimized video in the background, which is just like a nice kind of nice feature you can have with Cloudflare. And this is also possible on AWS, just to call that out. Queues. So if you want event-driven and asynchronous applications, then that's where queues will come in. You can publish message to a queue, and then you have a worker consume and process that message from the queue. It has all the kind of standard functionality you'd expect from a queue. So you have dead letter queues, which is the queue where the things go in when your messages fail too often, and it's failed maybe 5, 6, 7 times. It goes into what's called a dead letter queue, where you can see the messages that have just basically failed, and they're just sitting there until you action them, or eventually they'll just be deleted. And you can also, it will also retry jobs. So before it gets to the dead letter queue, it'll retry it a certain number of times, or you can delay jobs to say, send an email in 6 hours and you put a message on the queue, and then in 6 hours you can pick up the message and handle it if you want to. These days, AI is of course all the rage, is what everyone is talking about. So of course Cloudflare has some AI for you to play with. They call it Workers AI. And it has a large number of models that you probably will have seen if you've touched anything with AI, but it has models for speech recognition, embeddings, generative AI, and text to image, with providers such as Llama 3, Mistral, Whisper, and Stable Diffusion. And these are available globally via bindings, which I'll get onto in a minute because that's the kind of secret sauce. Couple more to go on the platform. You have Vectorize, which is a vector database, and these are used with GenAI. They're really kind of popular these days if you're using generative AI. And what they allow you to do, it's really quite complicated. I'm not going to claim to understand the maths, but effectively, if you remember your kind of high school, algebra, there's things called like cosine, and I can't even remember the other ones, but the cosine one is the main one I remember. But it allows you to see the kind of how closely related two things are. So you can take like dog and generate a vector, which will just be a series of numbers. You can take cat, and that'll be a different series of numbers. And then you can apply math on top of it, which the database will do for you to see how similar they are. I'll give you a score between 0 and 1, where 1 is it's the same, and 0 is it's not close at all. So if you did another one that was I don't know, desk probably wouldn't be too close to cat or dog. So it would have a lower score than dog and cat, for example. The last one, I guarantee you won't have seen anywhere else. People struggle to explain this, so I'm gonna do my best to explain this one. But they're called durable objects, and like I said, you won't have seen them before. And the easiest way I can explain is in your code you create objects. So let's say you have a class, you create a new instance of that class, and you use it. And then that request is finished, that object will be pulled out of memory, and the next time a request comes in, then more objects will be created and so forth. But what Cloudflare allows you to do is you can create a new instance of a class, and you can actually give that class to Cloudflare, or the instance of that class, and they will store it for you in its exact state, which is quite powerful because you don't have to worry about the storage. You can just say, give me a new user, say, hey, Cloudflare, store my user, and it will store it for you. And it's strongly consistent, so they guarantee to a certain point that the data is not going to be lost. And it's really good for real-time applications because it has native WebSocket support. So if you're building real-time applications like a game, for example, or Miro, maybe Trello, even Google Sheets, where it has who's on the sheet and what they're clicking on and stuff. A lot of those things use WebSockets, and durable objects allow you to do that. As I said, it has key value storage built in, and you can even execute these durable objects on alarms, so on a schedule. So you can say every 6 hours, every hour, whatever, wake up and do something, and then go back to sleep. So those are the core building blocks of Cloudflare, and they're nothing you probably haven't seen before, but it's just to show that it has everything you would need to build the majority of applications. This wasn't true maybe even 5 years ago. They've really developed their platform at quite an astonishing rate. The reason why I love it so much and why I think it shines is its developer experience. And I think it's incredibly important. And that's why I enjoy building on it. So I'm going to talk a little bit about the developer experience and the simplicity of the platform. So Wrangler, on the right is a random image. It's not Wrangler, just in case you're looking for the commands or anything. It's just a random one. But it's Cloudflare's developer platform command line interface. And this is basically what you'll do to do anytime you need to do something on the platform, you are going to use Wrangler. So if you want to run your application locally, you can run it with Wrangler, and it runs in the exact same environment that it would run in on Cloudflare servers. So you are running on your Mac or your PC, but it's the environment pretty much matches exactly what you would get in production, which is not true all the case if you're running, just Next.js just on your device. It's going to behave perhaps slightly differently than it would in production, but the two environments are basically the same. If you want to, rather than running it on your Mac, you can actually run it in a sandbox environment in Cloudflare. So you can develop locally on your Mac. Each time you change, it will push it to Cloudflare, and it will run it in like a sandbox environment. So that's even more realistic than running it simulated on your Mac. And if you want to deploy to Cloudflare's production servers, you'll be using Wrangler. Bindings. So these are the glue. So everything I talked about earlier, they all kind of fit together using bindings. Whereas in AWS or other platforms, and AWS does a little bit like this, but it's not to the extreme level that Cloudflare does it. Let's say you want to connect to a database, you need to know the username, you need to know the password, the port, the host, all these informations. You need to go and find probably some sort of library that allows is ready to connect to make your life easier, rather than writing, your SQL queries to the database just on your own. You're probably going to use a library, and you have to go find a library and then configure it. And you also need somewhere to store these secrets. You don't want to store them in plain text because that's not secure. So it just becomes a whole job of, you spend the whole day connecting your application to a database, for example. This is where binding comes in. And on the left is, this one is real. It's from Cloudflare. So this is what you would see if you had a Cloudflare project. And I would highlight, if I have a mouse, this bit here. This is the binding. And this is in a file called wrangler.toml. And what you would do if you wanted to have a cache is on your command line, or you can do it in the user interface if you prefer. You'd create a new KV namespace. And namespaces are just kind of the way you organize your caches. And it will give you an ID. And that's what you would pop in this ID field. And the ID is tied to your account, so you can't just change the number and access someone else's cache. It doesn't work like that. And then in the binding, you give it a name. And this is the name that you would use in your code. And I will try and show an example of this because I feel like it's quite powerful to show it in your editor. And what this basically does is when your application starts, it injects all of the bindings that you need when you receive a request. So a request comes in, you need your cache, your database, whatever else. You define them in this file, and you can split by environment. So this is like in a staging environment or a production environment. You can have different IDs. And when your application receives a request, you have access to all those things automatically without any credentials, any usernames, passwords, nothing like that. All you need is basically the environment which Cloudflare injects for you. And like I said, I will try and show that if I'm feeling brave at the end. Secrets work in a very similar way. So you don't want to be storing secrets in plain text. So Cloudflare has a way to store secrets per project, and it will encrypt them for you. And then in the same way that bindings work, it will inject your secrets at runtime. So there's no chance for those to leak because they're just encrypted. You can't once they're encrypted, you can't read them out of Cloudflare. That's it. So they're highly secure, and it stops you kind of losing things in plain text or revealing things in plain text. SSL and DNS. So if you want your application to be secure, you need things like SSL certificates, which can be a pain to set up, at least in the past. Cloudflare does this for you. So if you create a project today, it will create an SSL certificate for even your dev projects. And if you host it on a real domain, it will create an SSL certificate for your real domain too. It will rotate them whenever there is needed. And it's all for free. And it will also handle all the DNS and everything. And speaking of free, you can get started for free. So it has probably the most generous free plan I've seen. And it's not a free plan for a year. It's a free plan, forever. There's no 12-month gate like you get with AWS, where you get it free for 12 months and you have to pay. With Cloudflare, it's free always. And I've never seen them lower these limits. They've repeatedly said, these are, these are here to stay. They're not going to change them. So you don't need to worry about them suddenly disappearing. But if you take workers, for example, you can handle 100,000 requests a day for free. And 100,000 is quite a lot, especially if you're just starting out with your side project or hobby. The same goes for pages, because the back end of pages uses workers, so you get 100,000 requests per day, but they are shared between workers and pages. So if you have two workers projects and a pages project, they all share that 100,000 requests a day pool, but you get unlimited requests to static assets. So if you have a fully static website like a blog that you generate statically, you could host that Cloudflare on free, because they don't charge anything for static assets like images, CSS, HTML. It's all free. D1, so your databases, you get 5 million reads a day, 100,000 writes. So that's gonna take care of most applications with 5 gigabytes of storage. And then R2, you get 10 million reads a month and 1 million writes a month free with 10 gig of storage. If you go above these limits, there's a pay plan that's $5 a month that get ups your limits quite a lot. I think it's something like 10 million requests a month to your workers, for example. And then after that, there is incremental pay of, X number of requests cost X amount. So my slide says demo time. Do I want to debate? I will very quickly attempt demo. If it goes terribly wrong, then I'm just going to abort, but we'll try. Right, so if you were to, actually, I'll do this. Right, so just to show you what it looks like if you create a new project. You can see my terminal, right? Okay, cool. So this is what if you want to start a new worker project or a page project, you can use npm create Cloudflare, and you give it a name. So like a type. And then this is where it'll create a scaffold for you, depending on what you want to build. So it will do a hello world worker, which I'll show you in a minute. It will do a Python one. This website or web app is for pages. And if you were to click into this one, it would ask you what framework you want to use and all sorts of stuff like that. You can have schedule workers that run on kind of cron, so it will just run on a schedule. These are the durable objects I talked about. And you can even build a worker from a template. So Rust is a really popular one. I pick this one because it's nice and easy. It'll ask if you want, yes, no TypeScript. It will then install the dependencies. And then once it's finished, it would create your project like this. And there are two things I talked about. So you have the entry point and you have the Wrangler file. So this is what the Wrangler.toml looks like. This is where you put all your bindings, and you can see they're all kind of commented out at the moment. So if you just uncomment one, this one, for example, this would give you access. Oops. This will give you access to AI, for example. So there's no need to create a binding to access AI. Everyone has access to that AI binding. But for things like the D1 database, it asks you for the name you want to use in your code, the name of your database, and the ID for your database that you'll get when you create. And if you create, here's one I created earlier. So I did npx wrangler kb namespace create codebar. And that made me a namespace in kb. And you can just copy it. So if you take this and take that one out, put in here, this is now bound this worker to this namespace with this ID and this. And this is what you use in your code. If you look in the actual worker, this is what it looks like. So the entry point to any worker is defined in wrangler.toml at the top. You can see it's in here. And anytime this worker is executed, it will come into the fetch method and execute the code. So at the moment, it's just returning a new response that's hello world. If I were to run that, it's just npm dev. It's now simulating that locally. And if I open the browser, which I don't think you can see, but No, okay, you can't see that. But anyway, it opened in my browser. You don't need to really see that. And if I try and use the binding, you can do something like, just to show what it's like, env is where all your bindings are. So in your wrangler.toml, you called it codebar, which is always the name. So you do env.codebar.set. And this is the key name, and give a value of 1. Ignore the highlighting, it would work. And this is the kind of the magic where this would magically now be available to you. This will be effectively like a library that you can use, and Cloudflare maintains and injects this for you. You just call methods on it with what you want to do, and they will execute against whatever's bound. And you can bind as much as you like. You can have multiple namespaces and all sorts. But it really is powerful, and it allows you to move, in my opinion, very, very quickly. Quickly back to my slides. So that's the end of my talk. Thank you very much. If you want to learn more about Cloudflare, that will explain it in far more detail, and the demos will all be prepared, and they will probably all work. They're all in the book. Yeah, that's it for me.
Tom has asked a question, which is, what's your opinion on businesses adopting Cloudflare's developer products for their sole cloud infrastructure?
I think it's now approached the point where you definitely can. So my company is starting to use it a little bit because I'm nudging them. I think it's finding a good way to kind of showcase what it can do. So in my example, like I said, we host everything on AWS, but we do lots of kind of prototyping and tests. So we're now starting to use Cloudflare for kind of prototypes. So I'm able to, alongside a designer, very quickly spin up a prototype on Cloudflare that anyone in the world can access, that we use for like user testing. So if we kind of find random people and get them to test the prototype before productionizing it and building it further. And that's like a really powerful way I found to kind of show people how quickly you can build with it once you're up to speed. And secondly, how powerful the platform is. And then you can slowly integrate it more and more. So it started with pure prototypes that were running just in dev. And we have kind of a CMS migration going on where I work, and they want to run some A/B tests, but they can't because they're migrating between something and something. But with Cloudflare, you can do fun things like you can basically hijack specific URLs. So forget the platforms you're on, you can basically hijack the traffic with Cloudflare and have your B variant of your test effectively served via Cloudflare, and that's what we'll be doing next. So now we've moved from prototyping to enabling some quick A/B testing that could just be ripped down when it's finished. And then I'm hoping in future we'll move more towards building kind of full production grade applications. I don't think we're too far away, but yeah, I think it has the major building blocks that you need.
Perfect. Another question has come in. Have you run into any of their set restrictions when they have defined for workers? They have their set restrictions they have defined for workers.
And by set restrictions, do you mean the runtime?
Great question.
Yeah. Sorry, should I just save typing it out?
Yeah, no, it's fine. Yeah.
Yeah, there's some set restrictions on what memory usage. I can't remember what it is off the top of my head. There's one for the free plan, and then I think they upgrade it like 5x for paid, etc.
Yeah.
For their compute time, yeah.
Yeah, I think I've never hit the limits. I think if you're doing something that requires a lot of memory, then it's not for that. I don't think it can be used for everything and everything. I think it's very powerful for kind of APIs and full stack websites and things like that. I think the CPU limits again, I've never hit, and I haven't really encountered any problems with the packages yet. I haven't hit the point where I'm like, oh, I really wish I had this package. So yeah, I've not hit the limits, but I think I also, once you understand what it's capable of, you can kind of, what to build on it and whatnot. I don't think it's the point where you could build, I don't know, something that needs a gig, if you load a gig of something into memory, it's not the platform, but obviously that's where database and storage come in. But if you need a gig of memory and to process it in memory, then yeah, it's not going to work for that use case.